In this video, we're going to work example problems where we make use of the sum and difference formulas for sine and tangent, sum and difference identities. So if we take a look at the trig identities sheet, here's the sum and difference identities. And so we'll be using, for these problems, primarily the sum and difference formula for sine and tangent. Okay, so there's the formulas. For these first set of problems, we're given a trig function with an angle in the function, and we want to evaluate, get the exact value of each expression. So what is the exact value of sine of 165 degrees? And we worked problems like this. There were similar problems we worked with the sum and difference formula for cosine like this. And the idea is that before we got to the sum and difference identities, we could only find exact trig function values for either the special angles or quadrantal angles, or any angle that has a reference angle that's a special angle. So the special angle is 30, 45, and 60, or quadrantal angles. But now with the sum and difference formula, it's opened up the door to where we can find exact values of angles outside of the special angles, or reference angles that are the special angles. And what we've seen is that we can now get exact values for angles that are a multiple of 15 degrees. So 15 times 11 is 165. So we can find the exact value of this expression using the sum or difference formula for sine. So what we can do is we can say that sine of 165 is equal to, we'll do 135 plus 30. Okay, so 135 plus 30 is equal to 165. So we haven't changed anything. So, and now we can expand this out using the sum formula for sine. So this is going to be sine of 135 cosine 30 plus cosine 135 sine 30. Okay, so now if we think about the general definition of trig functions, 135 is 45 degrees past the vertical. So the reference angle is 45. And we know a 45, 45, 90 triangle, it's going to be 1, 1, root 2. So this is going to be positive 1, negative 1, root 2. That's 135. Okay, so sine of 135 is going to be, opposite of our hypotenuse, 1 over root 2. Okay, now cosine of 30 is, let's see, this would be 30. Okay, so that's 1 root 3, 2. So cosine of 30 is root 3 over 2. Okay, now cosine of 135, if we do cosine here, that's minus 1 over root 2. So let's do minus. Okay, then sine of 30 is 1/2. So the denominator is 2 root 2, and we've got root 3 minus 1 over 2 root 2. Multiply this by root 2 over root 2, and you get root 6 minus root 2 over 2 root 2 times root 2 is going to be 4. So root 6 minus root 2 over 4. Okay, tangent 165, we can do the exact same thing we just did. Write this as 135 plus 30, then get the sum formula for tangent. So that's going to be tangent of 135 plus tangent of 30 over 1 minus tangent (135 times tangent 30). Okay, now we can come to all of the what we drew in the previous problem. So, okay, tangent 135 is going to be opposite over adjacent, so minus 1. All right, minus 1 plus tangent of 30 is going to be opposite over adjacent, 1 over root 3. Okay, and then minus 1 times 1 over root 3, so that's going to be plus 1 over root 3. Okay, so now let's multiply this by 1 in the form of root 3 over root 3. So that's going to be 1 minus root 3 over 1 plus root 3. And I guess we could rationalize this by multiplying this by 1 in the form of 1 minus root 3 over 1 minus root 3. And we get, so 1 minus root 3, so that's minus 2 root 3. And then minus root 3 times minus root 3 is plus 3. Okay, over 1 minus root 3 plus root 3, and then minus 3. Okay, so that's going to be 4 minus 2 root 3 over minus 2. We can factor out a minus 2, and you get root 3 minus 2 over minus 2. And so you get root 3 minus 2. Okay, 5 pi over 12. 5 pi over 12 radians times the fact that you've got pi radians for every 180 degrees. So 180 divided by 12, 15. So, okay. That's 75 degrees. So this is equal to sine of 75 degrees. All right, so let's write this as sine of 30 degrees plus 45 degrees. Okay? So sine of 30 plus 45 is sine of 30, sine of 45, or no, cosine of 45, plus cosine of 30, sine of 45. Okay, so again, we've got the (30, 60, 90) and 45, 45, 90 triangles, which you should memorize. So here we've got 1, root 3, 2, and then 1, 1, root 2. And in fact, I'll go ahead and copy this. Okay, so sine of 30, opposite of hypotenuse, is 1/2. Cosine of 45 is 1 over root 2. Cosine 30 is root 3 over 2. Sine of 45 is 1 over root 2. So okay, so we've got 1 plus, okay, we can rationalize this, and so we're left with root 2 plus root 6 over 4. Okay, tangent of pi over 12, so we'll have 100, or no, it'd be pi radians for 180 degrees, so 180 divided by 12 was 15, I believe. Yeah. So this is tangent of 15 degrees. Okay, so we can write that tangent of 15, we can write as tangent, it's 45 degrees minus 30 degrees. So now using the difference formula for tangent, you've got tangent one plus okay. So tangent 45 is 1. Tangent 30 we can see is 1 over root 3. Tangent 45 is 1, and then tangent 30 is 1 over root 3, so 1 times 1 over root 3. Okay, so multiply this by root 3 over root 3. You got root 3 minus 1 over root 3 plus 1. So we can multiply this by, okay, so 3, root 3 times root 3 is 3, minus root 3 plus root 3 goes to 0, so that's just 3 minus 1. Root 3 times root 3 is 3, minus root 3 minus root 3, that's minus 2 root 3, and then minus 1 times minus 1 is positive 1. So 4 minus 2 root 3 over 2. So this is 2 minus root 3. Okay, 7 pi over 12 is how many degrees? So we've got pi radians for every 180 degrees. This is going to be 15. Fifteen times 7 is 105. So this is sine of 105. So, okay, 105, that's, okay, 90 plus 15. So we can do, we could do 90 plus 15 because I think we found sine of 15 degrees previously, but let's just stick with, what we can use from these triangles. So, all right, 60 degrees plus 45 degrees. Okay. So we've got sine of 60, cosine of 45, plus cosine of 60, sine of 45. Okay, sine of 60, it's root 3 over 2. Cosine 45, that's going to be 1 over root 2. Cosine 60 is going to be 1 over 2. Sine 45, 1 over root 2. So we've got root 3 plus 1 over 2 root 2. Root 6 plus root 2 over 4. Okay, same problem as before, but now we've got, it's minus. All right, so let's see. We had 45 plus 30, but now we'll do, let's do that, and we need to be careful here. So minus 45 minus 30 is minus 105, but we need to be careful. So we'll use the difference formula for sine. So that's, we've got sine of minus 45, and then it's going to be cosine of just 30 because we're using the difference formula. And then minus cosine of minus 45. Sine 30. Okay. Now, sine is an odd function, so we can take it, right, sine of minus 45 as sine of 45. Cosine is an even function, so we can just like that. Okay, sine of 45 is opposite of hypotenuse, so 1 over root 2. Cosine 30. Okay, cosine 45, and then sine 30. So minus root 3 minus 1 over 2 root 2. So minus root 6 minus root 2 over 4. Okay, minus 5 pi over 12. We just did that, right? That was 75 degrees. So now this is tangent of minus 75. So tangent of minus 75 is minus 45 degrees minus 30 degrees. Okay, so, all right, the difference formula for tangent, we've got tangent of A, so that's going to be tangent of minus 45 minus tangent of B, but that's just tangent of 30. We're using the difference formula. Okay, and then 1 plus tangent minus 45 tangent of 30. Okay, tangent is an odd function, so tangent of minus 45 we can write as minus tangent 45. And then same down here. Okay, tangent 45 is 1. Tangent of 30 is, okay, tangent 45 is 1, tangent 30, so this is going to be, all right, now multiply this by 1 in the form of root 3 over root 3. You've got multiply this by root 3 plus 1 over root 3 plus 1. You've got root 3 times root 3 is 3. Root 3 minus root 3 is 0, then minus 1. So 3 minus 1, and then minus 3 minus, let's see, minus root 3 minus 2 root 3, and then minus 1. So that's minus 4 minus 2 root 3 over 2, which is minus 2 minus root 3. Okay. Okay, tangent 11 pi over 12. So how many degrees is this? 11 pi over 12. You've got pi radians for every 180 degrees. That's 15. 15 times 11 was 165. So this is tangent of 165 degrees. Now, didn't we already do this? I think we did. There we go. Yeah, so root 3 minus 2. Okay, here we can notice that this is in a form that's, we have the difference formula for sine, with A being 76 and B being 31. So we can write this as sine of 76 minus 31, which is sine of 45, which is 1 over root 2. Multiply that by root 2 over root 2, and you get root 2 over 2. Okay, here we can match up with the sum formula for sine, with A being pi over 5 and B being 3 pi over 10. So this is sine of pi over 5 plus 3 pi over 10, which is, so 2 pi over 10, that's pi over 5, plus 3 pi over 10 is 5 pi over 10, which is pi over 2. So this is equal to the sine of pi over 2. That's 90 degrees. So we know that is 1. So this is 1. All of this is equal to 1. Okay. We can match this up with the sum formula for tangent, where A is 80 degrees and B is 55 degrees. So this is equal to the tangent of 80 plus 55, which is 80 plus 55 is 135. That has reference angle 45 degrees in the second quadrant. So we have a triangle like this in the second quadrant, but the x is going to be negative, right? So opposite over adjacent, 1 over negative 1, this is going to be negative 1. Okay, here we've got the sum formula for tangent, with A being 5 pi over 9 and B being 4 pi over 9. Okay, 5 pi plus 4 pi is 9 pi, so 9 pi over 9 is just pi, and tangent of pi is, let's see, y goes to 0, that's 0. So this, all of this is equal to 0.